Hi Professor, my name is Heng Lee. I would like to present my presentation for the healthcare robotic. The reason I choose this one because of healthcare industry is one of the major driver of robotic research and development in the US. Robotic is transforming healthcare industry, offering a new possibility for improving patient care, reducing costs, and enhancing surgery precision. From dedicated surgery procedure to rehabilitation, therapy, and patient assistance, robots are playing an increasingly crucial role in the healthcare. What is robot? Robot is a machine that can carry out a series of actions automatically. Slide number 2. Surgical robots are becoming increasingly independent, powered by artificial intelligence, machine learning, and sensor technology. The graph is the readiness level of lab enabling technology and research area for different levels of autonomy. Surgical robots are becoming more independent. This is due to advance in artificial intelligence, machine learning, and sensor technology. The graphs show readiness different technology for different level of autonomy, which is from level 1 to level 4. Level 1 is the robot assistant. Level 2, task autonomy, task automation. Level 3, conditional. And level 4 is high autonomy, close to fully autonomy. Slide number 3. Achieving task autonomy in surgical robot requires seamless condition between planning and control algorithm. Integrated planning and control framework provide a unified approach to execution, ensuring that the robot movements are optimized, safe, and aligned with surgical plan. Example in this picture, when the PSM1 is the manual by the user, PM1 by the user, and PM2 is automatic, it's mean by the robot in the yellow. So when PM1 manually controlled by the user with the circuit trajectory in red arrow, here PSM2 stably track and make contact attempt in the yellow when the tool target align become desirable. So when it's safely proceed, it will do automatically. Slide 4. Transition from a basic task automation to true surgical automation demand robot capable of understanding and the contact, anticipating potential complication and adapting to unfrozen situation. Common sense reasoning play a crucial role in enabling a robot to make intelligent decisions in a complex surgical environment. As you can see here in this graph, it have the automation from level 0, which is no automation, to fully automation level 5, and the general CS is contrasting with this automation. Slide number 5. These algorithms are essential for enabling surgical robots to perform tasks with precision, accuracy, adaptability. Trajectory optimization algorithm determine the optimal path for robot to follow. Sophisticated estimation algorithm track the robot position and the surgical environment. Vision-based control algorithm provide feedback from camera, and machine learning algorithm enable robot to learn from the data, adapt new situation. As you can see here, the image A, this is the STAR system, which stands for Smart Tissue Anastomosis Robot. And the image B, the system is equipped with the planotic camera to retrieve deep information, while the near-infrared camera detects hidden structure in the tissue. Here the near-infrared light that work with the NIR camera. Slide 6. Surgeons need to be able to collaborate effectively with robots in order to perform complex procedures safely and effectively. The research is focused to develop intuitive and natural interface that allows surgeons to communicate with robots, provide them with the information they need to make the decision. As you can see here, the level 1, the surgeon interact with the robot with which in turn provide the clinician with manual guidance or visual feature. In this case, the control loop is closed by surgeon who has the full control of the machine for the whole duration of the procedure. The level 2, the surgeon provides necessary information for the robot to accomplish a given task. Since during the autonomous execution, the control passes from the surgeon to the machine for the time needed to perform the action. We prefer this discrete control represented by the switch. Level 3, as you can see in the image, the system belongs to level 3, are capable autonomously define specification to plan and execute a surgical task different from level 2 system where the surgeon was supposed to provide them to the system. Slide number 8. Multi-robot system can be used to perform tasks that are too difficult or time-consuming for single robots, such as suturing or manipulating delicate tissue. Research in multi-robot coordinate for surgical robot is exploring strategy for collaborative task, conflict resolution, and task allocation among multiple robots. As you can see in the image here, the framework allows for dual-arm collision avoidance while maintaining decentralized planning. The minimum distance between the two tools is set to 10 mm, ensuring a 2 mm gap between them. Both tools consider each other as moving obstacle and initiate collision avoidance as soon as the process begins. By monitoring nearest obstacle point on the skeleton, the two maneuver around each other and retract their distal path to prevent collision. Once the other tool is clear, the tool resumes its two central and target-centric action. Multiple agent deep reinforced learning enables a robot perform tasks without explicit human instruction, leading to great autonomy, efficiency, and adaptability. This article reviews the latest multiple robot application paper that employ multi-agent learning techniques through the deep learning. It explores how these three concepts are integrated in the discussed study and provide insight into potential future advancement in this field, paving the way for progress in the state of art. As shown in the image, commercial available, this one, the systems are categorized by clinical application encompassing neurology, cardiothoracic, orthopedics, urology, and gastroenterology. If these applications could learn from each other and use the data over time, the advancement of robotics would be immense. This cross-pollination of knowledge would accelerate the development of more sophisticated and versatile robotic systems. As in the image slide here, it's the star perform the procedure for animals, and it proceeds significantly better result than human perform the same procedure. So it's a great success for robotic. What's the challenge? The challenge ensuring safety reliability of autonomous surgical robot through fail-safe mechanism and precise control algorithm. Develop robust algorithm that can handle complex surgical tasks in real time. Integrating autonomous surgical robot into a clinical practice with regulatory approval, surgeon acceptance, and standardized training protocol. What the future direction look like? Human robot collaborate, leveraging human expertise and robotic precision, harnessing AI and machine learning to develop sophisticated algorithms for autonomous surgical robot, enabling improved perception and decision making. Multi-robot system for complex surgery, requiring algorithm for effective coordination. And thank you. The last slide is the citation of the research that did for this project. Thank you.